Hey guys, welcome back to Access Engineering this Saturday. We're so glad to have you. This segment will be about electrical engineering. We'll be going over the very basics of electrical engineering, basically why electronics is even useful in our daily lives, which it is obviously, and the design process for electronics, a very important concept called Ohm's Law, which you'll see time and time again as you pursue higher education in this topic, and we'll go over a very simple circuit on a breadboard and Arduino. And if you don't know what those words mean yet, that's totally okay. We'll be going over them. So yeah, hope you enjoy.
Hi guys, so I am going to talk about why electronics. Electrical engineering is actually at the forefront of all the electronics you use every day and hold near and dear to your heart. Some examples are biomedical devices used to sustain life in hospitals, the cell tower and satellites used to get your text message sent halfway across the world to your friend, and as well as the phone that you probably have in your hand right now. These all require at least a basic level of electrical engineering to form their function. And once you see electrical engineering in the world, it is really hard to see the products and mechanisms that don't employ it.
Hey you guys, it's Michael here. So today I'll be talking to you guys about the design process for anything that you'll be making within this class, as well as within electrical or systems engineering. So basically the design process revolves around three main steps. So there's the schematic, there's the layout, and then there's the product. So the schematic is the first thing that you'll create within the design process. And this is something that is basically detailing the electrical hardware layout that you need to specify for your specific product or piece of electrical hardware. So as you can see within the schematic, you have many different lines connecting different components. And these lines typically correspond to wires that are just connecting, such as like your capacitors, your lights, ground, batteries. I know you guys might not know a lot of what these terms mean, but you will over the course of Access. So definitely stay tuned for what those words will mean, and we'll teach you guys along the way. And these components are just basically connected through electrical connections with wires. And that's what you specify within your schematic. And now moving over from your schematic, you're going to move into a layout. And a layout is definitely much more complicated than your standard schematic. It's not going to be just as organized as a schematic is, because the schematic is supposed to give you an overall idea of how your electrical hardware is supposed to be running, whereas your layout is the specific implementation of it. So it's going to involve a lot of different moving parts and pieces. So it can be a little bit tricky to make that step going from, just a 2D schematic to a three-dimensional piece of hardware that you need to stick within a product. So we're going to be helping you guys with that transition and showing you guys some really cool labs to hopefully make that transition easy. And then finally, the last step of the design process is your product. And that is basically taking the layout that you've created, which can often look extremely complicated or confusing, and putting it into a product that a person or a certain user group can use efficiently and effectively, and it's just easy to use overall. So an example of this is like your standard plug that you can see right here on the slide. Whereas the user or the people that buy the plug are only ever going to see the finished product, and that is, just the casing on the outside, and you just stick it into the wall to charge any of your devices. But what they don't know is that there's a lot of electrical hardware under the hood, and that's where the layout is being specified. So that layout is often hidden within many of your famous products that you guys know and love, such as your phones or plugs on your computers. So definitely just be on the lookout for how these layouts are implemented within your products. And you'll notice that a lot of times they're implemented in really cool ways. So yeah, this is the overall design process that we will be following here at Access and within electrical engineering.
Hey everyone, now we're going to be discussing the most fundamental law in electrical engineering, which is called Ohm's Law. And Ohm's Law essentially dictates the relationship between the voltage of a circuit, the current of a circuit, and the resistance. So let's look through each of these different quantities, I guess, and try to understand what they mean. So the current is essentially the electrons flowing through the circuit, which I think is the simplest thing to understand of the three. It's essentially like how many electrons are flowing through these wires per second. So it's kind of like velocity in physics, but think about current in electrical engineering. And then we have our resistance. And our resistance is measured in volts per amp or ohms. And essentially resistance is how hard is it for an electron to go through like the wire or the resistor. So resistors are part of our circuit and they have a lot of resistance in them, meaning that they restrict the flow of electrons going through the circuit at a certain point in time. And we need that to be able to control the flow of electrons in our circuit. If we didn't have any resistors, our components would burn out because there's too many electrons flowing through the circuit. So that's why we need resistance. And resistance takes out energy in the circuit. For instance, our light bulbs have resistance because they use that type of resistance to be able to create light. Because they burn the wires or they burn the wires to be able to like create light. And then our final quantity is voltage. And voltage is created through the batteries in our circuit. So for instance, we have a battery that has a negative and a positive end, and this creates a potential difference. And this is what really is driving the electrons to go from the positive side of a circuit to the negative side of a circuit. So the voltage is pushing the current to go through the circuit, to go through the resistors, and the resistors are the things that allow for the control of the electricity. And eventually for us to be able to, like, for instance, light up a light bulb. So, yeah.
Okay guys, so now we're going to be looking at our first ever circuit, and I'll be demonstrating for you with real parts in front of me. But if you were in the lab at Penn, you would all have these materials with you, and you'd be doing the lab like hands-on. So hopefully in the future you'll get to do that. But for now, we'll be just demonstrating that on video. So, okay. So right now I'm going to introduce the Arduino board, which looks like this live, and the diagram of that is right below here. And basically what this has is 13 pins, digital pins over here, and these supply power, and the pins labeled G and D, ground, are the ground pins. And basically what that means is that whenever you connect electrical circuit, you need a power source and you need a ground in order for the voltage to flow, which you learned in Ohm's law in the previous slide. So without those two, the circuit can't function. So the Arduino board conveniently provides these on the board so that you can connect your wires to these and make functional circuits. So yeah, the Arduino board is able to be programmed, and we'll be looking at that next week. But basically, you can write a program on your computer for basically anything. An example would be like an LED light turning on and off in a certain sequence, or if you had like a sensor, like a temperature sensor, you could set an alarm if the temperature went too high. Just like project ideas like that. There are a ton of ideas on the internet. If you just Google like Arduino projects, there are just so many. So that is due to the nature of the Arduino being like a programmable little computer, basically. Yeah. So the next part I want to introduce is a breadboard. So it looks like this with a lot of holes, and mine is quite large, but usually they are pretty small, like the one in the picture. So basically, the anatomy of this is described in the diagram at the bottom left of this slide. So basically in this, the far right and the far left, these columns are all connected with metal like under the plastic. And for the middle sections, each row is connected. So we want to keep these connections in mind in order to build our circuits. And also something we should remember is that the left and right sides are separated. So if you do connect something to the same row on the left and right side, but they're connected by this barrier, they actually won't be connected because they are separated. So yeah. So what we're going to be, and also another component would be our LED. So it looks like this. It could come in a lot of different colors, and basically when you do the circuit correctly, then this will light up. So yeah. Our last part would be the resistor. So basically, a resistor is, as you learned in Ohm's law in the last slide, it provides resistance to the circuit to make sure that there isn't too much current flowing through any component at any time. So resistors come in many resistances, and the unit for that is ohms, as we also learned before. And so this one is, I think, 1,000 ohm resistor, but honestly, you can use any reasonable amount for this circuit. And lastly, we're just going to be using 2 wires. And while you can use like any number of colors like this, we're going to be using black and red because by convention, the black one is used for ground and the red one is used for power. So we're going to be just using those in the circuit today just to help with the concepts. So yeah. So here is a quick circuit schematic, which we did learn that in the design process slide, but I just wanted to go over. So the 5-volt point would be corresponding to the 5-volt pin on the Arduino, and the LED is written on paper like this, and it corresponds to the LED light that I introduced, and the resistor, 1 kilo ohm resistor, is written as a squiggly line, and that's represented by this. And the ground is 3 lines, and it corresponds to the GND pin on the Arduino. And one important thing to remember and easy to miss is that there are 2 legs on the LED. So one of them is longer than the other. So it's important to remember that the short leg is the negative side and the long leg is the positive side. So it's important to connect it the right way, otherwise the LED will not light up. So finally, we'll be actually turning the LED on using hardware, meaning just using the properties of the Arduino and the breadboard and without programming it all. So we'll get to that next week. Yeah, so the first thing we're gonna do is connect our Arduino to our computer just because we need a power source for the LED to light up. So we have that. And the way we know that it's functioning is that it has a green on light. So I'm connected to my computer, my laptop now. So that's set. So basically, this is the Tinkercad version of the circuit, which means Tinkercad is an online software where you can put in a bunch of electrical components like on your screen and then connect them with wires. And it's a simulation that you can run from anywhere, and you don't have to have the parts in front of you. It's just a really great way to plan out your circuits and see if they will work and other effects before you actually build it. So we'll be going over this as well. So what we're going to be doing here is we're going to take our breadboard and we're going to connect our LED to it. So I'm just going to poke it in literally anywhere. Okay, so we have our LED on the breadboard. And as you can see, this is the long end and this is the short one. So we're going to take our resistor and connect it to, as it says in the diagram, we're going to make sure that one end of the resistor is connected to the long end of the LED. So because each row is electrically connected in the breadboard, we can choose any of the other 4 pins for in this row that's connected to the LED, this long leg. So we're just gonna poke the resistor in the next one. Sometimes this can take some time because the breadboard's holes can be a little bit tight, but we'll get it to work. Okay, so once you get your LED and resistor in the breadboard, so hopefully you can see that, we're gonna take our red wire, which symbolizes the power wire to the 5-volt pin on the Arduino. We're gonna put that connected to the resistor here. So we're gonna connect this end over here. Okay. And then we're gonna connect it to the 5-volt pin on the Arduino. So we can see this, right? So now we're gonna take our black wire and we're gonna connect this to ground. So we're gonna connect this to ground on the ground pin on the Arduino. And we're going to connect the other end of that to the unconnected end of the LED. So we're just gonna put that in there. Oh, and we can see that it's already lighting up. So let me just put that wire in there, and you can see that our LED is lit up just by the hardware. We don't need to code. We don't need to do any coding for this. This is just purely from the properties of this board. So yeah, our first successful circuit. So just a preview into next week, we'll be doing a little bit more of a complex circuit. We will be using code and just like basic code and explaining what the Arduino code does and different parts of it. So yeah, hope you enjoyed this week's lesson. This is our functional board, and if you happen to have these parts at home, just go ahead and try it. But I highly recommend using Tinkercad for testing out circuits. While it isn't as hands-on, it's really a good opportunity to figure out how the different parts work, and will make the in-person part like a lot easier. So yeah, thanks for coming this week, guys, and hope you enjoyed this week's lesson.